Yung ano. Okay. Now, going back, sabi nga natin, numerical methods, we have different processes. Kasi when you're trying to, alam nyo kasi ang engineering, yung engineering kasi, alam naman natin na ang engineering science of estimation yan eh. Diba? We estimate things. Siyempre, dapat talagang it's very realistic and kahit kung anumang field kayo, no, I'm not yet, I don't know what fields you are right now, pero sa lahat naman halos ng engineering fields, we use estimations. We try to omit some variables, lalo na kung at the end, maliit lang yung contribution niya dun sa overall problem or overall solution. So, such as ito, numerical methods, we're using iterative process to compute for the eventual solution. It may not be exactly equal to the perfect numbers or yung talagang exact numbers, not perfect, exact numbers, but still, it's very near. Okay? And it's acceptable. Okay. We have this problem, di ba? Again, upon reading, when we try to simplify the Lagrange method, di ba? The total cost, no? The total cost ng generation is sum ng cost per generator. Yan CI na yan, no? Cost per generator. Then yung cost ng bawat generator, di ba? Yung kanina, sample natin yung kanina, merong ano, no? Ito, 5P1. So, plus 0.01 P1 squared. Okay? So, yun yung cost of generator 1. So, in this case, wala nga lang ano doon sa kanina, 5P1 plus 0.01 P1 squared, walang constant value doon. So, wala kayong may lalagay na nandun sa alpha. Pero meron siyang yung coefficient beta, yung 5. Kasi 5P1. Tama? Then the gamma y is equal to yung 0.01. Kasi di ba 0.01 P1 squared. So, yun yung parts or components ng generator cost ng generator 1. Okay? So, going back, this is your, di ba sinam lang naman natin each. Okay? Dito sa, nakikita nyo ba yung mouse ko pag ginagalaw ko? Hindi. Nakikita, sir?
Kita, sir.
Kita,
Kita,
okay.
sir. Kita yung mouse.
Kita, sir. Kita.
Okay. Thank you. Kaya ito, itong component na to, di ba? We just sum kanina, di ba? Yung 5P1 plus 0.01 P1 squared, then yung para sa P2. Ito lang yun for each generator. Nakasum. Okay? Plus the lambda, okay? Times the G of X. Ito yung demand, di ba? Ito yung supply-demand balance constraint, which is yung demand minus the sum of generators. Okay. Now, if you, similar to what we did, di ba? If we get the partial derivatives kanina, if you get the partial derivatives ng mga yan, you will eventually boil, sinisimplify lang natin yung Lagrange kanina into these equations. Okay? Eventually, you will find yung generator output P ng isang generator I, okay, will be equal to, kasi ang lambda naman is common, lambda minus yung coefficient ng beta I, yung kasama ng first order na P, over, ano ba yung partial derivative kanina nung yung P1 squared, di magiging 2. So 2yi. Eventually, when you simplify that, this will be your for all generators, no? Okay? So let's not forget that yung Pi equals lambda minus beta I over 2yi. Okay? When we're using lambda iteration, ito, kayang-kaya nyo siguro to, no? Nagawa nyo na. Pipili lang kayo ng L tsaka H. Yung high value, low value. Okay? When you iterate, eventually, from your high to low, when you're trying to iterate, we will eventually get to a point, no? Magpupunta yan doon sa point na ano ba talaga yung final lambda. Okay? So ito yung process niya, di ba? Pick any high and low, get the midpoint of that first, try to insert yung midpoint na lambda m dito sa equation na to. Okay? Kung ano yung lambda m na yon, you will eventually get P1, P2, and P3. Kung ilan man generators yon. If the sum of those P, yung mga generator P na yon, using lambda m, is greater than, tapos dinidak mo sa demand, sabihin nun, sobra yung generation mo. Sumobra ka, kesa doon sa demand, pagka greater than 0, palta mo yung high value mo no midpoint. So kunwari, ito yung low, ito yung high. So pagka masyado mataas, palta mo yung high mo, punta mo doon sa mid. Okay? And then once you're in this next iteration, ano ba yung mid? Ito, nandito. Kung ginawa mo yung mid at lumabas doon, kulang naman yung generation. Total generation to the demand. So i-adjust mo yung low to the midpoint. So, pupunta dyan dito. Hanggang sa eventually, iterate hanggang pumunta dun sa pinaka-point na. But obviously, you will not, it's very difficult to get na yung final number, kaya numerical methods. That's why there's a certain tolerance. Na kapag yung difference na nung high and low, very minimal na, you stop there already. Yun na siguro yun, malapit na doon, sobrang lapit na doon sa final equation or final solution for lambda. When you get the final solution for lambda, kung ano man yung lambda na yun, yun yung makukuha mo for P1, P2, or how many generators you are given in the problem. So considering this again, balik tayo sa kanina, no, yung same problem. No? Let's insert this. Diba, ang lambda is ito, ang beta is 5 for P1, tapos over 2 times 0.01 kasi yung P yung gamma squared, 'di ba? Naging 2 gamma pag partial derivative. So, etong generator 1, you can see if we pick lambda h to be 20 and lambda l to be 0, yung midpoint natin obviously 10. Okay? So yung 10, pasok mo dito, 10 minus 5 over 0.02. Okay? And then yung isa, 10 minus 2 over 0.08. Okay? Ito yan, di ba? Ito yung per iteration. Sa first process, if we use 20 and 0, midpoint is 10. Pasok mo yung 10 doon, you'll get 250 for generator 1. Okay? And then you'll get 100 for generator 2. Your total demand in the first iteration or iteration 0, no? Where your demand is 50, sobra-sobra yung generation mo sa demand, di ba? Okay? If sobra yung generation sa demand, ano ba yung sabi? Paltan mo yung H nung midpoint before. Sa next iteration, paltan mo si H, kanina 20, papaltan mo siya nung 10, yung previous iteration na midpoint. So ngayon, ang bago mong H and L sa first iteration will be 10 and 0. Now, sa next iteration, your new midpoint will be 5. So yung 5 na yan, pasok mo ulit dun sa 5 minus 5 over 0.02, na 5 minus 2 over 0.08. Eventually, you'll get 0 kasi 5 minus 5 nga, no? And this one. So kulang naman yung total na generation sa demand. So next iteration, yung low point, papalitan ko ng midpoint dun sa previous. Okay, nakukuha ba guys? Nakuha pa ha? Pag may tanong, sabihin ha. So 10 and 5 and then you'll eventually get the midpoint ng 10 and 5, which is 7.5. Pasok mo ulit hanggang sa, you'll see here why we're putting the absolute difference between H and L. No, sabi dun sa kanina, it should be, you have a tolerance of 0.05. Ibig sabihin nun, dapat lower than 0.05 ang makuha mo. And we eventually will get down. During that process, magagawa niyo yan sa Excel, no? Kaya medyo i-brush up niyo yung Excel niyo, ha? So eventually, you'll get this. Kasi lower than 0.005 na to, no? Itong 0.0049. And we eventually will get yung lambda m. Di ba ito rin naman yung no? Yung kanina 5.2, tama ba? So now that's yung kanina, in the first place, dapat di na tayo nag-numerical methods kasi kaya naman isolve ng simple algebra to, di ba? But again, I'm just showing you, if you get to a point, tulad nung sa exam nyo, that's more than a lot, there's a lot of generators already that you cannot solve with a simple, you'll get to have to use numerical methods. Now, there's a lot of software already. Pero syempre, bago kayo pumunta sa software, dapat alam niyo yung fundamentals. Kaya ako tinuturo to. Okay? I'm just showing you also that you'll eventually arrive at somewhat near or maybe very near to the final solution. Okay? Now, pagka may limit, ito yung next na constraint. Okay? May constraint. Sabi, generator 1 has a P-min of 5 megawatts and a P-max of 20. Ano po ba yung P-min? Let's have ang mga generator, sabi nga maganda analogy din yan sa sakyan. Di ba pag natakbo yung sakyan, yung mga familiar pa sa sa mga manual na kotse. Okay? Yung mga manual na transmission, di ba meron niyang primera, segunda, tercera, yun yung mga primary gears, mga gears, no? Or transmission na Pagka tumatakbo ang sasakyan, di ba meron niyang parang speed na dapat tumatakbo siya. Kunwari, hindi mo naman pwedeng patakbuhin yung sasakyan mo ng 80 kilometers per hour kung nasa first gear ka pa lang. Okay? Pero syempre, pag automatic yung sasakyan mo, ibang usapan naman yun. Pero pag manual, hindi mo pwedeng gawin yun. So, just like generators, when you're trying to operate them already, tumatakbo na siya, okay? Dapat, merong minimum na tumatakbo siya. Kasi going below the minimum will result to that generator being unstable or not running at synchronous speed. When it's not running at synchronous speed, obviously, it will trip itself para to protect itself. So ayaw naman natin merong nagtitrip, di ba? Pag merong nagtitrip na generator, may nawawala, sinong papalit? Yung mas mahal na generation. Kasi in the first place, when you schedule generators, you're scheduling the cheapest. Pag nawala na yung naka-dispatch, ay di sino papalit? Yung susunod na mas mahal. Okay? So you don't want generators to trip. So also, Pmax is more sensible, di ba? Alam naman natin, all generators have a maximum capability. So itong generator 1 has a generator limit for 5 and then 20. Okay? So para magkakaroon ka nga lang ng additional process sa lambda iteration. Balikan natin yung example, no? So we use 0 and 20. You get the midpoint, which is 10. Pasok mo yung 10 dun sa lambda minus beta over 2 times gamma. Yung ito, di ba? Okay? Yung equation na nakuha natin dito, ito. Itong lambda minus beta. Okay? Pag pinasok mo, again, makuha mo yung P1. Similar to kanina, 250 yung P1, 100 yung P2. Okay. Pero, P1, pero generator 1, ang sabi, Pmax is 20. So, dun sa pinasok mo, sobra. So, ilagay mo siya sa 20. If the result of you inserting yung midpoint to the equation of generator 1 will result to a higher a P that is higher than the Pmax. Palitan mo yung P nung Pmax, which is 20 in this case. Okay? Kung siya ay mas mababa dun sa Pmin, palitan mo siya ng minimum. Edi ngayon, dito sa first iteration, 20. And then yung isa naman, kasi ang Pmax naman niya 35, 100 yung na-achieve mo, palitan mo ng 35. So magiging 20 and 35, which is equal to 55. Your 55 is still higher than the demand of 50. Okay? That would be resulting to a positive, di ba? Yung pagka-greater, papalitan mo yung midpoint ng previous na, yung low, yung high pala, papalitan mo ng midpoint before, which is 10. Bago mong high and low, sa next iteration is 0 and 10. Your new midpoint is 5. Gamitin mo ulit. Lumabas, 0, 37.5. Kaya lang yung 0 is lower than the minimum na 5 ni generator 1. Kaya papalitan mo naman ngayon siya ng 5. Okay? Kasi lower yung 0. It should not operate below its Pmin. So 5. Tapos yung 37.5 is higher than the Pmax ng generator 2. That's why we replace it with 35. So add the 2. 5 plus 35. Now we have 40. Kaya lang, yung 40 na yan is lower than the demand. Next time, papalitan naman natin yung low ng midpoint before. So yung dating 0, papalitan siya ng 5 based on sa midpoint before. Hanggang sa ma-achieve natin again, and you will get, medyo meron lang mga rounding off. Siyempre, again, if you want it to be more accurate, you have to have a stricter or lower tolerance. Okay? Pero dito sa case na to, since we only have 0.005, we eventually get, di ba 15 and 35 din naman yon, pero siguro 15.01 to 35. Okay? Now, because, babalik ako dun sa original, ang pinaka-final solution is around, yung P1 and P2. Eventually around 10, kasi pagka dinrag mo pa to further para maging accurate, 10 and 40 yan eh. Di ba? So, pero si generator 2 is only has a Pmax of 35. Mas mura si generator 2 at this point in time, 30. Pwede dapat siya mag-deliver up to 40. Kaso sabi nung teka lang, ang capability ko is only 35. Okay? I only have a capability of 35, but kung wala sana yung limitation na yon, hanggang 40 ka sana. Yun yung cheapest na solution, 40 ka. 10 yung generator 1. Kaso sabi, hindi kaya ko lang is 35. Now what do you see? From 5.2 pesos per kilowatt hour, na wala sanang limitation si generator 2, pero may limitation pala siyang 35, we result to a higher cost, incremental cost, lambda. Dati 5.2, now we have 5.3. Nakuha ba? Because whenever you're having a constraint, every time na may nalilimit, meron sanang cheaper, pero hindi ko ma-deliver yon, what will happen? Someone more expensive will deliver it for you. That's why from 5.2, we're resulting to 5.3. Okay? Alright. So, gradient search is just a different, just another method that's being used. Ito mas madali. Okay? Mas madali ito where I'll try to to have it shorter kasi sabi ko nga, na-review niyo na supposed dito dun sa modules kanina. Eventually, you'll have these equations for delta lambda k and your pk, delta pk is this much. So same problem, ang pinagkaiba lang, again, pili ka ng isa lang, hindi mo na kailangan ng high and low. Kuha ka lang ng kahit anong lambda. Alam niyo yung limitation nung kanina, nung lambda iteration. If you actually chose a high and low lambda value, na let's say, sabihin natin, ang chinus mong low is 10. Tapos ang high mo is 20. Kanina, ang chinus natin 0 and 20, di ba? Pero kung pinili nyo na low is 10, you will never reach 5.2, yung final solution. May stack up yun sa 10. Kasi di ba, ang problem ng lambda iteration is you're assuming that the final solution is somewhere in the middle of your high and low. Nag-iterate ka lang. Alright? Pero kung pinili mo 10, tapos 20, ang final solution pala 5.2, out of bounds nung limit na pinili mo, magsosolve lang yung pag ganon hanggang sa eventually 10, and you'll never get a solution where if you sum the generation na P1, P2, hindi mag-50. Kasi na-stuck na sa 10 yung lambda. Yun yung weakness ni lambda iteration. Ngayon si gradient search, you don't need that. You just need to select one lambda. Okay? When you select one lambda, you use it, and then eventually when you use it, you get P1 and P2. Okay? Compute for delta Pk, which is simply yung demand natin, 50, less yung total generation. So ang lumabas dito, 50 minus 250 plus 100 is equal to negative 300. So negative value. Your negative 300, ito yung formula nung change or delta ng lambda k, change in lambda k. is equal to the change in or difference ng PK, yung negative 300, over the sum lang nung 1 over 2y. Okay? So nakita dito, negative 4.8. So gagawin mo lang, ito yung sa next iteration, you get your current lambda plus yung delta lambda k. Now, ano ba tong alpha na to? Yung alpha is used as a sensitivity value para hindi drastic yung change. Kasi minsan sa mga numerical methods, pagka kunwari, okay, pag sinabi mong yung ngayon 10, sabi nung delta lambda mo is, magbawas ka ng 5. Bumawas ka. So, sabi natin, bawasan natin, wag naman saktong 5. Gawin natin 4. So from 10, bawasan mo ng 4, 6. Ay, sumobra ako. Ano pala dapat? Atras ka naman, 8. So masyadong drastic yung change mo, medyo tatagal yung solution. Pag may sensitivity ka, you're trying to smoothen the change para hindi ka mag-overshoot sa next iteration mo. Okay? Now for iteration 1, ito mas madali. 10 yung yung lambda mo minus yung delta lambda k, which is let's assume na 1 muna. 10 minus 4.8, 5.2. O pagka sinold mo uli yung 5.2 sa next iteration, 0 na agad, eksakto agad. So 5.2 agad yung solution. So mas mabilis, no? Si gradient search in this aspect. However, same with if we have another problem that is using generator limits. Medyo hahaba lang yan yung si gradient search. But still the same principle. Pag nakuha mo higher than Pmax, palitan mo kagad ng Pmax. Pag lower than Pmin, palitan mo kagad ng Pmin, yung P. And when you go through that process, you will eventually resolve to that same solution we got, 5.2 and 5.3. Alam nyo guys, kung may time kayo di ba yung sa exam nyo, sabi ko, use lambda, use gradient search. But if you actually solve everything, if you have time, you can resolve kunwari yung lambda using gradient para sure ka, if I achieve the same solution for lambda and gradient, sabihin nung tama na ako. Okay? So Newton's method, this is much, it's dealing more with matrices. No? Matrix naman. Matrices are a form of expression, mathematical expression, where we put it in into grid type na numerical values. Okay? So similarly, di ba, ito yung very long process nung kanina pa tayo nagdi-discuss about Lagrange. Di ba, ito yung partial derivative ng Lagrange with respect to x1 or with respect to p1 yan, with respect to p2 and eventually with respect to lambda. Okay? When you rearrange that, yung first column puro p1 dapat, second column p2, third column lambda, tapos yung right side dapat puro constant value. Okay? So pag ni-rearrange mo siya ng ganon, you'll eventually get this kind of form of matrix. Okay? Diba? If you for those who still remember, may review lang yung konti sa matrices, no? Diba? Diyan 0.02 P1 plus wala naman kasing P2 dun sa unang equation kaya 0. Plus kaya lang yung lambda nasa kabila negative, kaya naging minus lambda. Tapos nilipat mo yung constant sa kabila, you'll eventually get this kind of form sa matrix. So it is the same as the itong matrix form ito. Let's assume this is A. Itong pangalawa is B. And this one is equal to C. And yung matrices natin A, B, and C. Now in matrices, as a reminder lang, di ba? You can only multiply matrices if they have the same inner dimensions. Di ba ito ay 3 by 3? Ito naman ay 3 by 1. So 3x3, di ba? Times 3x1. Yun yung 3 by 3 times 3 by 1. So yung inner dimensions mo are 3, they're equal, so you can multiply them. So ang output ng product ng matrices will be outer dimensions. So 3 by 3 times 3 by 1, yung outer dimensions niya ay 3 and 1. So 3 by 1, which is, ito naman yun. So, para makuha naman natin ang unknown natin, di ba, P1, P2, and lambda. Okay? So So when you have an unknown of P1, P2, and lambda, you'll eventually transpose mo lang yung yung A. Di ba pagka tinatranspose ang matrix, hindi yan C over A, but rather inverse matrix ng A. Kaya A raised to -1. So your B now is equal to the inverse matrix of A times matrix C. Okay? You can now obtain the values for P1, P2, and lambda. Now, sige, demo lang ako guys ha. Doon sa, obviously, baka yung iba sa inyo alam na. I'll try to demo this in separate na screen, no? Okay, you see my Excel na, no? Nakita ba? Excel? Okay. So, sabi ko kanina, ano ba yung nandito? Kunin ko lang. 0.02, 0, -1. This is 0, 0.08, -1. And then 1, 1, 0. Diba ito yung P1, P2, and lambda. Okay? Ito yung matrix A, this one. This is matrix B. Alright? And then your matrix C kanina, -5, -2. And yung demand natin, di ba, 50. Okay? Nakuha niyo itong kaya nandito yung matrix na yan. Actually, part siya ng mga variable nito, di ba? P, ano to? Di ba nandito yan? Yan yun eh. Okay? Sa parang refresher lang ng matrices. Okay? Ito yan eh. 0.02 P1 plus 0 times P2 kasi wala nga P2 times lambda. Yun yun. So sabi, matrix ng A, inverse natin sa Excel, how to do that is just get, ano ba yung inverse? You can only get an inverse of a matrix if it's a square matrix. You cannot get an inverse of a matrix that is a non-square matrix pag mga rectangular. So ang square matrix equal yung rows and columns. So in this case, 3 rows, 3 columns. So pwede nating inverse. Okay? When trying to inverse, gawin nyo, yung lalandingan ng inverse ng matrix, i-highlight nyo 3 rows, 3 columns sa Excel. Yan, naka-highlight yan, di ba? Okay? While that's highlighted, while naka-highlight, try mong i-type equal M inverse. Okay? Habang naka-highlight tatype mo yan. Then punta ka dun sa ito, matrix mo. Don't worry, naka-record to kaya pwede nyo pambalikan. Naka-record tong session natin, okay? And then, while naka-highlight na, pindutin nyo lang yung control, shift, naka-hold yung control, tsaka shift, then press enter habang naka-hold yung control and shift. And you'll get this inverse. Gets? Okay. Now, di ba sabi, inverse ng A, sabi dun sa kanina, inverse ng A times C. Ano ba yung Kung 3 by 3 times 3 by 1, ano yung lalabas na output natin, sir? 3 by 1 din, di ba?
3 by 1.
Okay. Yung para makuha mo yung product ng matrix, kung 3 by 1 yan, i-highlight mo yung lalandingan uli, yung kung saan mo gusto lumabas yung solution. So kung 3 by 1, tatlong rows, isang column. Ito naka-highlight. Yan yung, dyan lalabas yung solution. So you type equal, habang naka-highlight, equal, M, mult, sabihin na multiply, times, highlight lang to, kung ano yung i-multiply mong first matrix na 3 by 3, times, lagay mo ng comma, yung array 2, nakita nyo, di ba? Meron nakalagay array 1, array 2. Okay? Yung second array, ito. Pag nakuha mo na yan, just click Control, Shift, hold mo lang, then press Enter. O, yun na. Isn't that the same solution kanina? Okay? Gets na? Okay. So that's the Newton method. Ganun lang kabilis, no? But eventually, that will be more more difficult, more. It will be tama, more difficult, less easier na lang. Oh, yan, less easier kapag may constraints na. So balik tayo dun sa constraints natin, no. Wait lang. Okay? Pag may constraints na, which will be further, well, ito yung process na yan, no? Yan. Yung full equation kasi, di ba, f of x, tama? Minus lambda times g of x, yan yung Lagrange. Pero meron pa tayong additional constraint, yung limit ng generator. Okay? So now, okay, meron kang pwedeng max. This is, etong in the same manner ng lambda, lahat ng constraints kasi may shadow price. Okay, may lambda, ito merong mu. Okay? So yung mu times P1 minus P max only in cases where you are hitting limits of generators. Okay. Balik tayo sa problem. Sabi, pagka yung unang problem, di ba, na-solve natin 10 and 40, pero si P2, more than P max niya. 35 lang yung P max ni P2, di ba? So, we have to fix P2 to 35. How do we do that with Newton method? So first, sasabihin natin, yung first equation natin, yung pa rin. Kaya lang makita mo yung Lagrange function ngayon. Yung pa rin naman, 5p1 plus 0.01 p1 squared plus 2p2 plus 0.01. Sorry. This is p2 pala. Sorry. 5p1 plus 0.01 p1 squared plus 2p2 plus 0.04 p2 squared. Okay? Plus lambda times demand minus p1 minus p2. But now, you get in the same, itong part na to, no? You get plus mu2 max times p2 max minus p2. Pinagpalit ko lang guys ha. Dito kasi minus mu max. Pero p1 minus p max. Pinagpalit ko lang. Ilipat ko yung max dito para maging positive na lang to. Okay? Alright. So ito na yung full Lagrange equation mo. Ilan na yung variable natin? P1, P2, lambda, and now we have a new mu2 max. Yung mu na sign. Okay, this is the shadow price for the limit of generator 2. Maximum limit. So apat na. Try mo i-partial derivative yung Lagrange with respect to P1, with respect to P2, and eventually with respect to lambda, and with respect to mu2 max. Eventually, you'll get 4 equations and 4 unknowns. Pero pag makikita mo sa dulo, di ba guys, makikita mo, parang dating nito, magiging, pag nilipat mo yung P2 rito, P2 will be just equal to P2 max. So sa fourth equation, ginagawa mo lang, siniset mo na si P2 to be at 35. So yun lang yung ginagawa. Okay? So ito yan. The equation na yan. You have now 4 matrix, 4. Same process lang din. Pag sa matrix, di ba? Inverse mo to. Gets? Di ba? Inverse. Ito naman, given lahat, times ito. Eventually, you'll get this one. Okay? Gets pa ba?
Sir, may question ako, sir.
Sige.
Yung sa KKT condition, sir, yung mu kasi, sir, sabi doon must be greater than, where mu is greater than or equal to 0. Pero yung answer natin sa mu2 max is negative. Okay lang yun, sir.
Hindi. Constraint equation yun, sir. Hindi yun yung magiging value mo. Constraint equation. So, ganito, di ba? Balik ako dito. Yung condition yun, hindi siya solution, hindi siya yung sagot. Condition siya.
Opo.
Ang KKT is a condition. Kung titingnan mo, di ba, if you remember, di ba yung g of x, di ba, should be equal to 0. Yun yung condition mo. Ito naman, mu2 max times p2 max minus p2, yung condition na yan, will eventually be equal to 0. Which is ito yung in-achieve natin dun sa fourth partial derivative.
Opo.
Okay?
Okay.
Okay?
Opo.
Sige. Alright. So, hindi siya solution. Hindi yan yung sagot. Okay? Iba yun.
Opo.
Alright. That's a condition. Now, ano ibig sabihin? Yan. Diyan na tayo pupunta. No? Ano ba ibig sabihin niyang lambda? Ano ba yung ibig sabihin ng mu2? Okay? Actually, guys, ang ibig sabihin ng lambda, sabi ko nga kanina, di ba? Ang unit of measure ng lambda, it's called incremental cost. Pero ang unit of measure niya is peso per megawatt hour or peso per kilowatt hour. So parang it's peso per the wattage. Yun yung unit of measure ng lambda. Tawag sa kanya incremental cost. Ayoko kayong i-confuse ha. Sabihin ng again, cost is unit of measure ng cost, peso. Pero pag tinawag mo kasing incremental, increment, 1. Diba? So that's per megawatt. So incremental cost is somewhat similar to a unit of measure of price. So at this point in time, na 50 megawatts ang demand, and you have these limits of generator, the cost of electricity, the next megawatt will cost 5.3 pesos per kilowatt or per megawatt hour. Pag 5.3 pesos per kilowatt hour, that means it's just 5,300 pesos per megawatt hour. Okay? So, bakit ba natin ginagamit yung 1? No? Sa mga economics, yung unit of measure na increments of 1, kasi, syempre, alam ka namang very simple, hindi mo kailangan ng scientific explanation. It's easier to represent all items in increments of 1. Minsan ginagamit natin 1, di ba? Minsan yung percent ginagawa natin 100%, di ba? It's easier to explain a lot of things with increments of 1. Kasi kunwari, sabihin mo, sir, ano yan? 10 pesos per 0.5 kilowatt hours. Parang hirap explain, di ba? Why not just say 5 pesos per kilowatt hour? No. That's why you use only 1 as a significance or numerical value for increments. Okay? Very lang, hindi naman siya kailangan scientific. It's just very basic na to understand units of measure. Okay? Di ba pagka per kilo ng bigas, 50 pesos per kilo. Alam mo sabihin mong, sir, ano yan? 100 pesos per 2 kilos. No? Why not just say 50 pesos per kilo? So, yun lang din yun. So, that lambda is a unit of measure na yung sa system will cost an electricity of 5.3 pesos per kilowatt hour at that time na 50 megawatts ang demand. So another megawatt will cost 5.3. However, ano ba yung mu2? Yung mu2, ano ba yung limit natin? 40 ang dapat na generator output sana. Kaso na-limit siya kasi ang output lang talaga niya or capacity niya is 35. Okay, anong ibig sabihin ng negative 0.5? Ang ibig sabihin niyan, guys, if you try to solve the same problem again, try natin ha. I-share ko yung yung Excel para makita niyo. Okay? Going back to this one. Okay? Ano ba yung cost ng ano ba yung cost, 'di ba? Peso. Tama? Okay. Ito kasi cost of electricity, pero hindi ito yung generation cost. Ito yung representative ng cost ng blend ng generation. Okay? Kasi magkaibang generator to, may generator 1 ka, generator 2. But what really is cost? 'Di ba ito 10 megawatts? Ano ba yung natin kanina? 'Di ba 0.01 P1 squared, 'di ba? Tama?
0.01 P1. Opo.
Tama? 'Di ba yan yung plus 0. Let's go back. Balikan natin. Plus 5 P1. 'Di ba? Yan eh. Yan yung yung fuel cost, tama? Okay?
Yes po.
Yung isa, yung generator 2.04 P2 squared plus 2P2. Yan yun.
2P2.
Okay. Pag sinabi mong 10, ano yung fuel cost ngayon? Di ba gagawin mo lang 10 square, di ba? Tama? 0.01 times. Ako ba?
Opo.
P1 squared. Okay? Move ko to para medyo sayang space. Tapos, yung 5P1, simply just 5 times 10, di ba? Sum niyan, ayun yung fuel cost. Di ba yung F1 is 0.01 P1 squared plus, ano ba to? 5P1, di ba? O, sum niyan, yun yung fuel cost ni generator 1. O, ulitin natin dito, 0.04 P2 squared. O, yan yun. Plus 2P2. And yun eventually, yung sum niyan. Ito yung F1, ito yung F2, tama? So yung total cost, sum mo lang yung dalawa, di ba? F1 plus F2. Yan yung cost, 195. At yung sa problem natin. Okay. Alright. Now, sige. May equation na tayo, di ba? Laruin ko na lang tong nandito. Ang final solution ng meron limit, di ba? 15. Ako na lang. Ito natin lipat. 10, 40. Ito yung ano eh. Okay. Ganyan. Now, this is 10 and 40, di ba? Now, balik tayo doon sa may limits. 15, 35. Yan yung ano, di ba? Kinukuha ko lang yung cost, guys. 15 and 35 yung with limits. Ang cost niya, balikan natin ha. Case 1. Ang cost ng 15 and 35 will be 196 and 0.25. Yan yung pesos. Peso equivalent, di ba? Peso yan, cost. Okay. What if sana walang limit si generator 2? Again, per megawatt. What if kaya pala niyang mag-deliver pa ng another megawatt? Ano sana yung maging cost? O, ano ba yung additional megawatt? From 35, dagdagan natin 36. Tama? Okay? Kung wala sanang limit. So, kung dinagdagan natin ng 36 to, dapat bawasan natin to ng 1 kasi 50 lang yung demand mo eh. No? Okay. So, yung case 2 is 14 and 36. Okay? Yan yun. So, we'll get the difference nung cost. So, roughly around 0.5. So, ang ibig lang sabihin yan, nakakapagpababa sa, kasi negative eh, no? Cost would have been lowered by 0.5 peso per kilowatt hour should it have been able to produce 1 more megawatt. Para saan yun? Para saan itong mga ganitang measure? It just goes to show, kunwari nag-i-invest ka or gusto mo someone to invest ng generation facilities sa area mo. You will have to study what is its benefit sa inyo. Ito na yung benefit sa kanya. And this is a measure na parang ito yung benefit sa system. No? Is it really okay lang bang magtayo ng plant kung ganito ang ibababa ng rates natin? Or not. So yung kesa gawin mo pa yung simulation na yan, okay? You already get that from the mu, the shadow price. Okay? Question ba? Question? Kung wala. Sige. Let's take a 5-minute break. Then we'll continue with the next modules. Okay, 5-minute break lang, guys. We'll continue with the next modules. Again, Yung mga bagong login lang, no? Don't worry, lahat na nagsimula kami kaninang 5, it's recorded. So if you want to go back to those discussions, nagsimula kami sa pinaka first module eh. We'll go back to those discussions and it will be uploaded, no? Again, sabihin ko lang yung mga instructions ko for the rest of the days. Mamaya uli, I will repeat it para dun sa mga kakalagin lang. But let's take a 5-minute break lang. Let's resume immediately. For those who cannot log in anymore, kasi may gagawin, may lakad, baka tinatawag na ni Mami. No, joke lang. Ano ha? Again, this is recorded. Just tell, you can actually download this. This is just live now, but you can download it. Para at least yung may mga questions, you can ask more questions later. Again, I'll repeat what I've said to the guys who logged in earlier, to those who just logged in, okay? Sige, break muna tayo, 5 minutes lang.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Based on our problems before nga, normally we'll deal with problems that are using a representation where it is lossless because we never represent yung equations ng lines that eventually exhibit yung lines na yon have their own physical characteristics which contribute to losses in the system, no? And that losses is in the form of yung resistance, yung R component. Whenever current flows through that line, square of that will be times the resistance will be your losses. Hindi, isa pang laging tatandaan guys, in power flows, M bars or megavars in power flow, hindi yan nagfo-flow guys ha. Even if your loads have M bars because ano ba yung mga lines, mga loads na may M bar? Those loads are normally yung mga like steel mills, arc furnaces that have heat, contacts with metal, they eventually lead to M bars, high amounts of M bars. Pero hindi yan ano no, it affects the system. Pero ang solution diyan is it's either you have generation na available to emit M bar near it or you have capacitor banks. Pero hindi ibig sabihin na ipapa-flow mo yung M bar. No, M bars don't flow. It's only the megawatts that flow, no? Ang load flow is more on megawatts, not M bars. But M bars is a result of that load flow, no? And how you deal with it will be through different means. Okay, so again, in a realistic system, you have transmission lines where there are losses. Again, as an example, you have two generators that have identical characteristics. 70, let's use this example, 70 yung Pmin, ang Pmax is 400. Whereas, but P1 is connected to a different bus here. And while generator 2 is connected to a different bus alongside the load. Again, buses are just representation in the power flow or sa power system as common connection points. They are not really the physical bus bars. Now, sa bus na to, if they're identical, one solution would be initially to split them, yung load requirement nito na 500, to split it to equitably dun sa dalawa, tig 250. But because P generator 1 has to travel or has yung power niya should travel this line, there will be losses. In order to, there's a solution where one solution would be, well, dagdagan mo yung output ni P1 para makompensate yung losses dito to eventually deliver 250 here. So 250 here plus 250 by P2 will result to 500 para sakto doon sa load requirement ni load. But again, as we've already mentioned, power system problems are quadratic. It doesn't mean one problem or one solution would be, bakit di na lang i-maximize si P2 from 250, gawin na lang 400, and whatever remaining, deliver na lang ni P1 para ma-minimize yung loss. But again, that's not the optimal solution because whenever you increase the output of P2, you have to square it. Ito yung cost function. So lumalaki, quadratic siya. Okay? So to put it simply, you have to go back to the Lagrange equation. Formulate the Lagrange equation again. Do the partial derivative with respect to the different variables. You will have this equation. Eventually, ang naging solution is not maximizing P2, but definitely mataas din. But not maximizing it to 400. Whereas P1 will be 178.88. With this, they can still deliver 500 to the load. Ito kasi 178.88 minus 6.38 will be equal to 172.5. And with that, 500. Pero ang cost lang nun, if you put the power, the megawatt output in the cost function niya, again, yung cost function ito. Pag nilabas mo itong 178.88, pag pinasok mo rin itong 327.5, you'll eventually have a cost of 4,623. Which is cheaper kahit na yung sinabi ko kaninang solution na ang mag-compensate nung loss si P1 kasi that will result to 4,661. And even if you try to really minimize losses na i-maximize si P2, it will still have a much more expensive cost than the one we solved properly. Okay? So yun yun. Okay. Now, similar to going now, let's proceed to optimal power flow. As I've said, power flow, or sometimes we call it load flow, is just how you try to find out what really will be the state of the system. Kung ito yung loads, ito yung generators, pasok mo dyan, sa there are lots of power flow softwares already available. Ito yung load, ito yung gen, you have your transmission lines and your transformers. Eventually, you'll have a power flow. O, ito yung schedule. And then you adjust from time to time to really meet yung mga constraints mo. That's more brute force. But if you want to inculcate already the cost, so part na ng optimization yon. So you're trying to solve optimally kung ano yung dapat na delivery of power to the load. Similar to kanina, bakit natin discuss yung losses kanina? Similar doon. If there are two different generators, alam nyo, isang analogy, sa pang simple analogy. Let's say, ang load nasa Metro Manila. So, lahat naman dito, again, as I've said, lahat naman dito, taga-Pilipinas, nanggaling dito. No? Let's say we have a load that is in very far sa North Luzon. Okay? And then, way north, let's say. And then there's another generator na nasa Batangas lang. And ang load natin nasa Metro Manila. Malapit, obvious. Sabihin natin yung load yung generator na isa kanina nasa Ilocos. Yung isa nasa Batangas. Obviously, mas malapit yung Batangas sa sa Metro Manila. Generator sa Ilocos, let's say, offers an output, offers a rate, let's say, of power na, let's say, 4 pesos per kilowatt hour or 4,000 pesos per megawatt hour. How, on the other spectrum, yung sa Batangas, ang in-offer niya, let's say, 4,100 pesos per megawatt or 4.1 peso per kilowatt hour. Question is, you're trying to deliver power to to Metro Manila, siya na yung nagre-require. Who would you choose to produce power? It will always boil down to, okay, yung isa 4.1, yung isa 4, pero yung generator sa Ilocos na 4 has to produce, let's say, 300 para lang makaabot dun sa Metro Manila. Whereas si 4.1 only has to produce, let's say, exaggerated example, it has only to produce 200 megawatts. Okay? Yung 4.1 times 200, that will 4,100 times 200 megawatts, so 4,100 pesos per megawatt. That will eventually result to 820,000 pesos of generation cost. Kasi 410 times 4,100 times 200. So 820,000. While as yung nasa north, na nasa Ilocos, 300 megawatts times 4,000 peso per megawatt, that will be 1.2 million. Diba? So, ano ba yung cheapest ngayon talaga? O di cost-wise, it will be cheaper to actually produce or have the generator in Batangas produce 200 megawatts at 4,100 na rin. Kesa yung 4,000 times 300. Diba? So, again, we're trying to minimize cost. We're not trying to get the minimum price. Yan yung lagi nyo tatandaan. Okay? So, load flow can help us with that. Now, linear programming, as I've said, using that to solve for the optimal power flow, imbis na yung katulad nung kanina. So, we will try to medyo magbabago ng konti yung perspective. Kanina kasi puro quadratic. Pero dahil puro quadratic, pero medyo yung quadratic, when you really solve it, it takes time. There's a lot of translation, there's a lot of derivation. Eventually naman kung maggagawa ka ng software, you can automate everything and you can make it faster. Siyempre, pag mga power system problems, masyadong malaki yan. Okay? So, pagka kunwari, like sa Philippines, we have hundreds or almost 1,000 buses. Medyo mahirap nang i-solve yun, no? Napakahirap na. That's why we're resorting to some simplifications like linear programming. Okay? So the LP standard form is that you have a cost function where it says, let's say yung Z is your cost function, and that will just be C1. Isi-simplify pati cost ng generator. Imbis na quadratic, gagawin mo na lang rate. Parang yung katulad ng example ko, 4.1 peso per kilowatt hour na lang yung buong equation na mahaba. So, let's say your cost function Z is equal to C1x1 plus C2x2. So, ito yung mga generators. Itong ST means subject to these kinds of constraints. So, meron kang load flow constraint, and eventually you have your X of J. Now, power flow equations are equivalent to these values. QK, QK. Sir Rob, pamit na lang. Yan. Okay. So ngayon, since lahat ng power systems, lalo yung transmission, yung R component is very, very small with respect to the X component. What does it, why am I saying this? Kasi, di ba ang impedance, that will dictate how power will flow. Yung Z, alam niyo naman yung Z. Z squared equals R squared plus X squared. Now, if your R, kasi gusto mo talaga sa transmission system, small r So, ginagawa yung mga transmission lines as much as possible. Very minimal yung R. Okay? So, yung R, with respect to X, kasi X is an inherent characteristic talaga ng AC. Pag dumaan ng AC power through a line, you will eventually have inductance and capacitance, and which will result to a resultant of inductance pa rin naman sa transmission. So, if you get that, Z, if you have a very, very small R, let's say, sample na natin, 0.001 ang R. Pero yung X, 0.2. If you solve for Z, and you can look at this again, yung Z mo, mas malapit sa 0.2. Okay? So, if malapit siya sa 0.2, and maliit lang talaga yung contribution niya sa power, sa load flow ng R, No, R is important and hindi ko naman sasabing hindi important yung R when solving, no? But still, you have to deal yung R for losses. Pero pag flow, power flow, you can already simplify and just use the X. That's why we call it a DC power flow. It's not direct current, but it's it's just a reference to DC na direct current, pero AC pa rin naman, pero you're using X only. Okay? Also, in in a DC power flow assumption, you're trying to the angular difference between buses across all buses is very, very small. So eventually you have this approximation. Okay? So I'll try to be fast, no? Kasi medyo late na rin. Let's say we have this example of a power system. We have 3 generators, P1, P2, and P4. Whereas yung load natin nasa bus 2 and bus 3, itong arrows na to. Ito yung requirement nila. When we say Y means this is admittance. Admittance is just the inverse of reactance. So, ibig sabihin nito, if you go this, ang reactance nito mga lines, kung negative J10 ang admittance, that means inverse niyan, 0.1, J 0.1. Diba? J 0.1 ang reactance itong mga to. Okay. Now, for those, sino ba dito familiar sa Y-bus? Meron bang familiar? Y-bus? Guys?
Meron po.
Meron naman. Okay, sige. So, sa Y-bus, when you're formulating a Y-bus, you have the diagonals here. So, ilan ba yung buses natin? 4 dito sa problem na to. 4 na bus. We have 4 buses, 3 generators, 2 loads, and we have 5 transmission lines. Okay? Now, eto, your bus, this is your admittance, yung B. Okay? So, dun sa diagonal element, isasum mo lang lahat ng admittance na connected doon. Okay? Yan. Alright. Now, dun naman sa off diagonal, kukunin mo yung admittance between that diagonal. Okay? Sige. So this is the process for that. Okay? Now the Y bus, kung kukunin natin 'to, di ba? Sa bus 1, ano ba yung mga connected na admittance? Ito, negative J10, negative J10, negative, tatlo na negative J10. So sum of it, sa bus 1, you'll have negative 30. Okay? Ganun din ang gawin mo sa bus 2. Ano ba yung connected sa bus 2? Dalawa lang. Isang negative J10 ito, isa pang negative J10. Kuko na lang yung transmission lines. You'll eventually get negative 20 sa diagonal 2. You repeat that for diagonal 3, for bus 3, eventually for bus 4. How about yung off diagonal? Nagkataon lang equal lang dun sa example, pero sa exam nyo magkakaiba yun. So sasabihin, what is between dito, bus 1 and bus 2? So row 1, column 2. So between bus 1 and bus 2, meron ba? 1, 2, o meron naman talagang transmission line between bus 1 and bus 2. So, negative J10. Pero sabi dito, multiply it by negative value, kaya naging positive 10. So you do that for all the off diagonals. Nilabas lang yung J dito sa labas. Ito na yung Y bus. Okay? Ignore nyo lang tong B prime muna, ha? Ignore nyo lang muna. Okay? Now, next. Ano naman yung node arc incidence matrix? O sige, try ko mag-screen share, ha? Ibahin ko yung share ko screen, yung aking buong screen. Okay. So sa Y bus natin, okay? Negative 30, yan yung nakalagay, di ba? Negative 20, negative 30. Again, kasi 4 bus. So, nasa labas lang yung J. Then we have 10 here, 10. Ganon, yung kanyang process kanina. Nagkataon lang, equal lahat. Okay, we have this. We have this Y bus now. Okay. Now, yung node arc incidence matrix naman. Kanina ito yung galing sa ano natin, yung D times A. How do we get the A? Yung A, or yung node arc incidence matrix, will be how many numbers of, you have to determine how many buses and how many lines. We have, ilang lines? 1, 2, 3, 4, 5. Okay? So these are your number of lines. Yan yung number of rows mo. Then we have 4 buses. Okay? We have 4 buses here. Now, ang sabi sa rule ng node, if the branch is away from the node, put 1. If the branch is towards a node or towards a bus, you put -1. So from +1 towards -1. So ang gagawin natin, babalik tayo dito, you just assume. Assumption lang. Parang you remember your KCL naman, no? Yung Kirchhoff's current law. Yung assumption naman doon is, kunwari, magka-assume ka ng ganitong direction. Pag naging negative, it just means just the reverse of that. Pero ito, assumption lang. So let's say ito, transmission line 1. Ang assumption, it goes from bus 1 to bus 4. So when you do that, sabi from, di ba? So from, this is your bus, di ba? Okay? And this is your line. Sabi sa line 1, from bus 1, so +1, towards bus 4, -1 dito. And then you just put zeros dun sa hindi naman relevant na bus. Kasi hindi naman relevant sa line 1 si bus 2 and 3. You do that again for line 2, from bus 1 to bus 2. So from bus 1 to bus 2, then put zeros here. Line 3, here. Line 3, ito. From bus 2 to bus 3. Yan yung assumption. From bus 2 to bus 3. Line 4, from bus 4 to bus 3. So from bus 4 to bus 3. And then lastly, line 5 is from bus 1 to bus 3. Okay? So ito na yung node arc incidence matrix natin. Whereas ito yung Y bus. Okay? So we got that already. Okay? Your D matrix on the other hand is just the diagonal elements ng admittance. O line 1, ano yung admittance? Nagkataon lang, 10. Pero in this case, kung iba yan, dapat you put the right element. So sa line 1, 10. Line 2, 10. Sa diagonal, line 3, 10. Nagkataon lang equal siya. Then all the off diagonals will be equal to 0. Now, ito yung D matrix kasi ito eh. Ito yung A matrix. Now, in this example, inumit yung bus 1 kasi ginawang reference yung bus 1. But in our example mamaya, babalik natin yung bus 1 ha. Okay? And then, going back to the minimization nung natin, cost function, minimize Z, your cost function, subject to these load flow constraints. Ililinearize na natin yung quadratic function ng generator. So, imbis na katulad na kanina na mayroong 4 plus then 4P1 plus 0.01 P1 squared, magiging isa na lang coefficient. Sabihin mo na lang 5P1, yun na, linear na lang. Okay? So, let's say in this example, cost ni generator 1, 13.07 P1 lang. For generator 2, that's just 12.11 P2. And for generator 4, just 12.54 P4. Okay. Now, ilan ba yung unknown natin sa power flow problem? We have unknown P1, P2, P4. Your power flow at branch 1, yung line 1, PB1 means branch 1 eh. Line 1. So may 5 tayong linya. Ano ba yung magiging power flow sa mga branches na yon? Eventually, we have the bus angles to determine the voltage. For each bus, we have 4 buses, kaya may theta 1, 2, 3, 4. So when you put it in matrix form, di ba ano lang yan, 13.07 times P1 plus 12.11 times P2. So ganun yan, di ba, pag matrix form. Wala namang cost yung pag-operate ng line eh. So kaya naging 0 siya dito. Okay. Now, this is your equality constraints. How do we translate ngayon yung power flow na A equivalent X times B equivalent? So ilan po ba yung ano natin? Unknown natin. Balik tayo. P1, 2, and ano ba yung power ni generator 1, 2, and 4? Ano yung power flow sa branches 1 to 5? And ano yung bus angle sa 1, 2, 3, 4? So we have 3 generators, 4 branches, and 4 buses. So total niyan, pag kinahon mo, 3 plus 5 plus 4 is 12. So we have 12 unknowns. So we'll have to determine 12 values. So in our matrix, there's a 12 by 1 matrix. Let's assign that to be your A equivalent. Now, for our power flow or load flow constraint, para ma-build natin yung load flow constraint, we have to determine the number of rows. So, ang number of rows natin is equal to the number of branches plus the number of buses. So, we have 5 branches and 4 buses. Total is 9 rows. Okay? So, if you have 9 rows and 12 unknowns, our A equivalent will now be 9 by 12. So, ganun yung kalaki yung matrix natin. Again, going back, ito yung D matrix, di ba kanina? D times A matrix. Ito yung complete na A kanina kasi kanina kinat eh. Same nito. Ito yung A. Di ba? Yan yun. We have the D matrix. Lagay ko na rin dito yung D matrix. Yung D matrix, kung ano lang yung sa branches will be at the diagonal, di ba? So 5 by 5 yon pagka D, number of branches. So this is your D matrix. If again, basahin nyo na lang ulit yung ginawa ko kanina sa Again, this is recorded. Yung paggamit ng Excel for matrices. I'll just get the product of D times A matrix. So ang 5 by 4, yung 5 by 5 yung D, pero yung A mo is 5 by 4. So we will get a 5 by 4 na output. So D times A. O yan. Yan yung ating D times A. Okay? Which is the same dito. Pagka multiply yan, 10, 10, negative 10. That's the same. Okay? Now, you put dito sa portion na to, sige, lagyan ko ng mga boxes. Itong portion na to, ito yung D times A. You'll put that, kasi 9 by 12 yung A equivalent natin, di ba? So sa right side, at the top right, first 5 rows, pero last 4 columns, ito yung D times A. Ayan. Okay? Ito namang portion na to, will just be get the negative, kasi ito yung branches mo, just put negative ones in the diagonals. So 5 rows, 5 columns. And then the rest, ito, will just be zeros. Kasi these first 5 rows are dealing with the power flow of the line. So we don't have a cost here. So yan na yan. And then eventually you'll get this first 5 rows na values. Next, Di ba kanina meron tayong B prime, yung ating ito, yung ating Y bus, o nakalimutan, may kulang na dito. Itong Y bus na to, yan yon. Okay? Yung Y bus na yan, okay? Ito yung Y bus, pero para makuha nyo yung B prime is just the negative of the Y bus. Okay? Yan yon. So, multiply mo lang ng negative lahat to. Eventually, you'll get ito. Right? Now, once you get the B prime, lagay mo yan sa lower right here. Dito. Next. Since dito sa last 4 rows, we'll be dealing with the generators. Wala namang cost sa line. So, put all zeros dito sa lines na part. Para kasi sa lines to eh. If you transpose this to each of these, para sa lines kasi itong section na to. So put zeros here. And then the last one, di ba? Generator 1, ito yon, dito siya. Generator 2, nasa bus 2. And generator 4, wala naman siya sa bus 3. But rather, nandito siya sa bus 4. Is equal to, ito yung ito yung branch requirements. Wala namang branch requirements tayo, no? Wala namang nakatap na load sa branches. Kaya yung first 5 rows dito are all 0. Ito namang last 4 rows dito sa right side are the load requirements. Di ba ang load natin ay nasa bus 2 and bus 3. If you go back to the drawing. Nasa bus 2 and bus 3. So dahil load siya, ang load sa power system is negative. Kasi ang generator naman is positive to maintain that balance. Okay? So 1 per unit, tsaka, and ito 1.1 to. Yan na iba to. And you'll eventually get ito, yung load requirement na yan. Yan. So you now have your A equivalent times X. Okay? Yan lang muna yan. Yan na yan mismo. Huwag muna natin galawin yan. Yan na yung form. Yan na yung matrix equation ng A equivalent X. Mr. Maceda, may tatanong ka ba? At nag-off ka ng mute? No? Sige, wala. Okay. Now, for the inequality constraint, dito natin ilalagay yung mga constraints ng generator. Like kunwari, si generator 1, now we are representing this in per unit. Pag per unit, usually our convention is our base MVA is 100. So, if this is 0.5 per unit ng generator, that will be 50 megawatts. Yun yung PMIN niya. Times 100 to 2, that will be 200 megawatts. So, per unit ang representation, guys. So, ito. Makikita nyo, meron ditong less than or equal dito sa sides dito. So this means that your generator 1 should operate between 0.5, not lower than 0.5, but not higher than 2. So the same for generator 2, meron lang ibang parameters, and for generator 4. Now for the branches, ang clerical error ko lang dito, this is this is actually 5, not 500, kasi the line is 500 megawatts eh. So in per unit, that's 5 only. So ito negative 5 to 5, yun yung limit ng linya. And eventually, our angles, bus angles, should operate between your negative pi to pi. Now, ito yung kaninang function natin na minimize z of x. Ito yung kaninang equation kanina. Ito yung A equivalent x. Ito naman, yung kanina. And this is the inequality, yung huli. Okay? Yan na yung standard form of linear programming. That's it. Tapos na. Okay? Yan lang ang i-require ko sa exam 2 nyo. Okay? But actually, if you have MATLAB, you can actually solve for those values. Okay? And you will eventually get, ito yung dapat na generator output, ito yung magiging branch flows, ito yung angles. So ito yung drawing representation niya. Yun yung resulta ng power flow natin. And if you want to further simulate that, ito yung code for MATLAB to build our example kanina. Okay? Right. Do you have any questions, guys?
Sir, okay lang sir na sa MATLAB isolve tapos i-input na lang sa Excel. O dapat formula pa rin sa Excel.
You don't, sa exam nyo, you don't have to solve. Ang kailangan lang yung ito. Yan. Yung standard form ng LP. You have to show the ano ba yung, kunwari, bibigyan ko kayo ng power system problem kasama yung topology niya. Yung katulad nung kanina. Nung sample ko kanina. So, you have to get the LP-OPF standard form. But, yun lang yun. Kasi eventually, for me to check, I will get this para ma-solve ko sa MATLAB ito. Yung ginawa nyo. Okay? Ang sinasabi ko lang guys, yung kanina equations, ito yun in MATLAB form for you to get the final solution. Binibigyan ko lang kayo ng reference if you want to do that. But obviously, not all of us have MATLAB. Okay? Questions ba? Okay. Okay, balik lang ako guys. Again, dun sa mga naka-attend nung earlier session which we started around 5. As I've said, I will give you another chance to resubmit yung yung exam 1. Deadline will be on Wednesday, 11:59. Sir Jim Har, pa-mute muna, sir. Okay. So I'll give you until Wednesday evening, 11:59 p.m. para ma-resubmit yung yung inyong first exam. Lalo na dun sa issue ng may losses, no? Your second exam is already available now in Blackboard. Some were able to verify na available na. The videos that we have right now, kasi na-save naman to, recorded siya. So I will upload this also dun sa mga naka-miss. Or if you want to review again, we can go back. You can go back to the videos. Modules 6 to 11 will be uploaded also today after this session for you to read. Your exam number 2, deadline then same time on Wednesday kasi sa Thursday na yung bigayan ng grade. Deadline also will be on Wednesday at 11:59 p.m. Now, but since medyo it's partly also again as I've said dun sa mga hindi pa nakakilala sa akin, yung hindi ko nasabi kanina yung mga naglagin lang. I'm sorry if I was not able to start immediately, but ang promise ko naman even if the term ends, I will still hold 3 to 4 more sessions to eventually discuss also some of the details, lalo na yung mga interested sa economic operations, no? In the power system. I will still hold sessions. Part-time job ko lang kasi si Mapua, and I'm working in the Philippines, operator of the WESM. So availability ko lang talaga is Saturday and Sunday. So I can schedule more sessions, and then yung sessions na yon, even if after this week, I will still have sessions up until March. That you can still download, maging available naman sa Blackboard lahat ng recordings. So you can still download, you can still attend my live sessions. If the sessions, if you're not available, you can always download the links. And I will still conduct classes for you until 1st to 2nd week of March for us to complete everything. Okay? Do you have questions pa? Joseph, Tommy,
Wala na, sir.
Mr.
Okay na sir, thank you so much.
Mr.
Okay na po.
Miguel,
Thank you,
Mr.
sir.
Manda, Mr. Maceda.
Sir, thank you po.
Okay
sige.
na po,
Just
sir.
wait for the uploads. If you have questions again, sabi ko nga kanina, email me at yung Yahoo mail ko. Hindi ako makacheck sa Mapua mail. Okay? you have questions. Okay,
Yes,
so
sir.
I'll see you if you
Yes,
don't,
sir.
you still are not able to receive some of the lectures and some of the recordings by tomorrow morning. Please inform me immediately through my email para ma-consult ko rin
Yes, sir.
yung Mapu administrator. Okay?
Okay, sir.
Sige, salamat.
Yes, sir.
Thank you for attending.
Okay, thank you rin, sir.
Thank you, sir.
Thank you.